All right, you guys, so let's look at logarithmic functions, which are the inverse of exponential functions. Okay. Now, as we go through this unit, and actually now that we're starting logarithms, we're going to kind of flip-flop between exponential functions and and logarithmic functions because they're inverses. All right. So don't be surprised after today if I start talking about exponential functions because they're interconnected. All right, so let's jump right in and let's look at this PowerPoint. Okay. All right, it says logarithms answer the question of what? It says how many of one variable do we multiply to get another number? Okay. That is a very loaded statement. Okay. But honestly, it's just a fancy question or statement for what is the exponent. Okay. So if I had 2 to the exponent, okay, so and I'm not going to say what the exponent is, but if I had 2 to the what equals 4 or equals 8 or equals 16, what is that exponent? Okay. And logarithms help us answer that question. All right, so look at this example. It says, how many 2's do we multiply to get 8? Well, here's the answer. 2 times 2 times 2 equals 8, so 3. Therefore, the logarithm is 3. Okay, the logarithm is 3. That would be the exponent. All right, so how to write it properly. So we write the number of 2's. We need to multiply to get 8 is 3 as log base 2 of 8 equals 3. So that's what this right here, if you see my mouse, log base 2 of 8 equals 3. So now you've got two statements now that are exactly the same. 2 times 2 times 2 equals 8, and log base 2 of 8 equals 3. Okay. All right. So, and that may not, you might be looking at it and going, wait a minute, how are those two things the same? Remember, 2 times 2 times 2, that is 2 to the third power. Okay. So these two things are the same thing. Okay. All right, how to say it properly. So the number we multiply is called the base. So we can say the logarithm of 8 with base 2 is 3. Okay, I don't say it like that. So if you're looking at this picture, I say this one. Log base 2 of 8 is 3. But I need to be a good teacher and tell you all the different things that you might hear. Okay, base 2 log of 8 is 3. So looking at that example, okay, over here on the right, that is just 3 ways you can say it. The one in the middle, okay, I read it left to right. Log base 2 of 8 equals 3. And honestly, I think, but that's just me. That's the best way. All right, notice something, okay? We are dealing with 3 numbers, okay? So there's a lot going on in this problem. You've got the base, okay? So 2, that's the number we are multiplying, okay? So we're going to be multiplying 2 times 2 times 2 times 2, okay? The logarithm, okay? How many times we are multiplying the base? So that's here, 3, okay? And then the answer, okay, well, what are we taking the log of? 8, the result of the multiplication problem. So 2 to the third power equals 8. All right, so now let's just look at some examples. And some of it, you may be looking at it and going, Barfield, I can't do this off the top of my head. Trust me, I got a plan. Okay, so it says, what is the log base 5 of 625? So how many 5's do we need to get 625? All right, you can see it right here. 5 to the fourth equals 625. So log base 5 of 625 is 4. What is the log base 2 of 64? What am I asking you? How many 2's do we need to get 64? Well, 2 to the 6th power equals 64. So log base 2 of 64 equals 6. Okay? All right. Exponents and logarithms. All right, so now you can kind of see in these two pictures how they're interconnected. It says the exponent says how many times to multiply the base. So a logarithm answers a question like this. So if you look here, 2 to the x equals 8. what is the value of x? Or log base 2 of 8 equals x. What is the value of x? Okay, so if you look up here in your pictures, remember this exponent is 3, this is your base is 2, and look how it translates here. So if I have 2 to the third power equals 8, that is the same as log base 2. Notice the base of the logarithm is the base of the exponent. And then the exponent, okay, is your answer. Okay, because remember, that's what a logarithm is doing. Okay, it's helping me solve for that exponent. All right, now I know this picture on the left is a little blurry, but this is just that general case. So no matter what the numbers are, how do I rewrite it? And that's what we're going to be doing also in our Delta Math assignment is rewriting, okay? If they give you an exponential equation, how do you rewrite it as a logarithm equation? And then can you do the reverse? If I give you a logarithm equation, can you rewrite it as an exponential equation? So you got to be able to go back and forth, okay? But here's the thing, I'll say it again. The base of the exponent is the base of the logarithm. The exponent is your answer, and then y, notice here, that's what you're taking the logarithm of, okay? All right, so we have some just other logarithms that exist in our world today, and you need to know what those are. So the first one is common logarithms. So sometimes a logarithm is written without a base, and that's not me being lazy, okay? So if you have ever seen maybe a brother or a sister who's in an upper level math class write out their homework, I mean, one, yeah, their homework probably looks like a foreign language, but, okay, they're not being lazy. So if I were to write log 100, okay, it's actually there. We say log base 10 of 100, okay? So this usually means that the base is 10. I'll talk about that in a minute. Engineers, okay, if you're going to go into engineering, we love base 10 in engineering. Okay, the calculator button. Okay, so when you press the button on the calculator, for some of you, you've been staring at a calculator for years and it has the word log on it. Well, what is it? Well, this is it. Okay, it will have base 10. A calculator is automatically built to have base 10. So right here, okay, if you can see my mouse circling, okay, we have an understood base. Well, that understood base is 10. What do I mean by usually? Okay, there are some mathematicians out there who have some really bad habits, and they may start out a paper and make some kind of declaration at the beginning of the paper that they're in base 2. And then from there on out, they'll never write log base 2. Okay, that is not good practice, okay, because it ends up being confusing. All right, so that's why we put the caveat of usually. Okay, but in our world, I promise you, in our world, base 10. Okay, if you see log and you see 100 and you don't see a base, you are safe to say it's 10. All right, natural logarithms. Okay, so another base that is often used is e. Okay, and if you remember from the other day, we had to type in e into our calculator, okay, or into Desmos. This is Euler's number, which is about 2.71828. Okay, now I'll be honest, I look at it, I'm like, oh, that's Euler's number. No, it's Euler's number. Pronunciation is how it is. Okay, this is the natural logarithm. Okay, mathematicians love it. Okay, it is the calculator button that says LN on it. Okay, so if you look over here, okay, so LN 7.389, that's the same thing as log base E of 7.389, which is about 2, because 2.718 squared is approximately 7.389. Okay, but that's how it looks in a problem. Now, unfortunately, we do not have enough time in this class for me to get into the background history of E. This is just one of those things like pi. You know pi is 3.14. I know that E is 2.71828. we're just going to move on. Okay. You are welcome to research it if you have extra time. All right, let's talk about some confusion. And this is exactly what I'm talking about. Mathematicians also have some bad habits of using log instead of ln, to mean natural logarithm. And like I said here, it's a bad practice, but it happens in way upper level mathematics. So when you get into college and if you're studying to be a mathematician, you're going to probably encounter professors who are they just start writing and they don't care what they write and they mean natural logarithm, but they write the word log. Okay, so all I can say to that is be sure you know what base you're in. Be sure, here's how you avoid that confusion. Write the base in the proper location when you're writing examples in your work. So look over here at this picture. It says example, log 50. What an engineer would say. Okay, that's log base 10 of 50. A mathematician might say, well, no, that's log base E of 50, which there establishes confusion because who's correct? Is it the engineer that's correct? Is it the mathematician that's correct? Okay, which is why we have these two other approaches. Ln of 50, okay? An engineer knows that that's log base E of 50. A mathematician knows that's log base E of 50. There's no confusion. So when I write Ln, the engineer and the mathematician think the same thing. Okay, if I write log base 10 of 50, the engineer and the mathematician know the same thing. Okay, now I understand that up here I said, if you didn't see it, you get to assume base 10. Okay, this is just why there's confusion. Okay, but thankfully for you, hey, that's hopefully like a few years away when you all decide that you're going to go and major in mathematics because you absolutely loved Miss Barfield's class. All right, so what about decimals? So I've done all these examples now for you and I've not mentioned anything about a decimal. All right, so you can have decimals. So if you consider log 26. So if I were to escape, let me move half my screen over. Let's pull up Desmos. All right, so if I type in log parentheses 26, okay, you can see Desmos gives me a decimal answer. That's perfectly okay. All right, and the answer here is 1.41497, which means, okay, this is what this means. It means 10 to the exponent of 1.41497 will equal 26. Well, let's type that in the second line so you can see that. Okay, so 10 to an exponent of, now if you round it, so I'm going to show you what I've typed in the PowerPoint, 41497. Okay. Look right here. See how it is if I round 25.9999. If I round it up to 26, I'm good. But just know, okay, remember, you learned a long time ago that when you start rounding decimals, you no longer have an exact answer. If I want to get the exact answer, let me show you what I have to type. 10 to the exponent. And watch, I'm going to put it in parentheses, log 26. That's how you get the exact answer because the log of 26 is a decimal value, okay? And even Desmos has rounded this decimal. I don't know how many decimal places this answer truly is. But if I type in a rounded exponent, I get a rounded answer. Okay, but if I type in the exact decimal value, okay, which log 26, the exact decimal value, okay, when I put it as the exponent, I'll get my answer of 26. Okay, so that's just kind of how it comes full circle. Okay, so just know decimals are okay. All right. So, negative logarithms. All right, now I'm not going to lie. This is where most people are like, all right, I'm with you. I got it. And then it falls apart. But it's really okay. So negative, you say. Logarithms deal with multiplying, but the inverse operation of multiplication is division. So a negative logarithm means how many times to divide by a number. What do I mean by that? All right, so let's look at these examples. Okay. It says, what is log base 8 of 0.125? Okay, so log base 8 of 0.125. Well, all right, so I know some things. I know that 1/8 is 0.25, so the fraction 1 over 8. I also know that 1 over 8 is equal to 8 to the negative 1. And if you don't believe me, type it in your calculator. Therefore, okay, this little exponent was the key. Log base 8 of 0.125 equals negative 1. All right, what about this one? What is log base 5 of 0.008? Okay, well, I know that 1 over 125, so 1 over 125 is 0.008. And 1 over 125 equals 5 to the negative 3. Don't believe me? Type it in your calculator. But see how I have that exponent? Therefore, the log base 5 of 0.008 is negative 3. Thinking this might be a bit much? There's hope. Give me a couple slides. All right, look here at the table, and hopefully that will start to make a little bit of sense in terms of what's going on. All right, so we've got these numbers. We've got 1,000, we got 100, we got 10, we got 1, we got 0 0.1, 0.01, 0.001. Okay, so if we're going up the table, we're multiplying by 10. If we're going down the table, we're dividing by another 10. Okay, so log base 10 of 1,000 is 3. Okay, if you look over here, it says in the how many tens column, think about how those are rewritten as exponents. Okay, think about how I could rewrite that as an exponent. I could rewrite that as 10 to the third power. So log base 10 of 1,000 is 3. Look here, log base 10 of 100 is 2. Here, log base 10 of 10 is 1. So that's 10 to the 1 power. Well, 1, that's 10 to the 0. Okay, 10 to the 0 equals 1. All right, now, if I do 1 divided by 10, so log base 10 of 0.1, well, that's negative 1 because 1 over 10 is 10 to the negative 1. Okay, log base 10 of 0.01 is negative 2. Well, this is 1 over 10 squared, or 10 to the negative 2. So 1 over 10 squared, or 10 to the negative 2. That's right here. So that's why the answer is negative 2. Well, if this is 1 over 10 to the third, or 10 to the negative 3, my answer is negative 3. Okay? Some of you might need to just stare at that for a little bit and let that absorb. Okay? But what if you're still thinking, Ms. Barfield, I can't figure these out in my head. Okay? I can't figure out any of these in my head. Like maybe you're just not good with exponents, or you've never really gotten really good at your fractions and your decimals. Okay? Here's a little secret. I'm not great with it either. So what do we do when we're stuck? We have what's called the change of base formula. So need help with those pesky decimal problems? Okay, so consider log base 8 of 0.125. Look what you're going to type in your calculator, and it's going to spit out the answer. Okay, so what it is that the change of base formula says that if I have log base b of x, I can take the log in base 10 of x, which is just log of x in my calculator, divide that by log base 10, which is just the log button in my calculator, of b. Okay, so x over b. All right, so let's bring up Desmos again. Let's delete this out. Okay, so you're telling me if I type in log of 0.125 divided by log of 8. Okay, so log of 0.125 divided by log of 8, -1. Okay, now let me pull up the slide. Where was it? Let me go right there. See? You see what I highlighted? Right there. Okay, log base 8 of 0.125. So I went through that whole explanation right here. I didn't need to do that. Okay, because I can just type it in. I can type in log of 0.125 divided by log of 8, and I get the answer of -1. Okay, and that's how I would solve any problem, okay, that I didn't know. Like if I go back through all of these examples, okay, where these decimal ones especially, okay, so if I were to take this one, I would type log, okay, of 0.008 and then divide by log of 5, -3. Okay, so you're going to use your calculator to kind of bail you out, so to speak. Okay, all right, I will come back in video number 2 with your Delta Math assignment and how to make sure that you understand what we've just presented here and how do I directly apply that to problems. Okay, good luck, you guys.